Hi everyone, from time to time I like to buy a new piece of gear for the electronics lab, and sometimes it's just a tool, and this time it is this digital caliper. Now in the electronics lab these are certainly not essential, but they're handy to have around, and they make just measuring, I don't know, things like this barrel connector a lot easier than playing around with a ruler. But as I say, not essential, and quality doesn't have to be top of the range. Now over the last few videos you may have seen me using this set, this Mitutoyo, and this is really nice to use. It's very smooth, very repeatable readings, etc, etc, very well manufactured, and kind of a little bit spoilt with it, but this will set you back about £90. Overkill for the electronics lab. But it will kind of be my baseline as I look at this one. So this is a Preciva, and the main reason that I chose it, apart from the fact it got star reviews all over the place, was the size of the LCD display, which is I think 18mm high, 4-digit display of course, and yeah, it's quite nice. Just wind that out there. Let's say 4-digit, it'll be 4.5 digit. There we go. And yeah, it's quite a nice display. And the reason, of course, is because I'm videoing a lot. So I figure a large display would be helpful to have in the electronics lab for that very reason, although it is extremely reflective. So I figure it will be worthwhile just having a little look at this, seeing what I think about it, making a few comments about it. Most of the reviews I've seen are just, oh, it's a lovely big display and it works fine and the faces are parallel, and that's about all they have to say. There's one guy who has tried to put a bit more detail in his review on Amazon, but yeah, some of the things he says I'm not entirely sure are quite right. Now, first things first, this comes in a box. It's got this, we've got the low molded box, which is perfectly adequate for putting this in. It comes with a spare battery and a little instruction book, of course. And so I thought, as well as just having a quick look at the caliper, I would make a few comments about sort of taking how I judge whether this is good, bad, indifferent, and one or two of the things that I want to get clear in my mind before I use this to make measurements. Now, this is an electronics lab. I'm not making ultra precise measurements, and some people say, oh yeah, well you're measuring down to 0.01 millimeters. Well, no, you're not. That's its precision. There's an accuracy to take account of. On top of that, there's a usage accuracy to take on top of that. And in truth, if I were using this in, let's say, my metalwork workshop to make parts with a accuracy of plus minus 0.01 millimeters, then this isn't the tool I'd be using. I'd be using a micrometer instead with an additional decimal place. But just because it's got one digit on the end doesn't mean that's really useful to measure down to that precision. Okay, let's think about some of the characteristics that are important in a digital caliper and some of the things that we want to know when we're making measurements. And while we're doing that, we'll also think about the biggest source of error in a digital caliper, which is the user and how we use them. Full disclaimer here, this is not an unboxing. I've already taken this out a couple of days ago, had a look at it. I've also made a tiny adjustment to it because it needed, there's two screws in the top which tension a tensioning bar, and that wasn't properly tensioned from the factory. So I've tightened that up, and that has brought these jaws into proper alignment, so that's good news. And also means that it now runs a lot more smoothly along its entire length. I also had to take the back off because it had an unusual amount of slop in it, and that's because some of the screws underneath this little label weren't tightened up. So quality out the factory, I wasn't that impressed. Let's look then at its normal mode of operation. So there's three measurements we can take. We can take measurements between these jaws, which is the most usual way that we measure things with a pair of calipers. We can take measurements on this step gauge here, and we can take a depth measurement using this as a sort of parallel surface and a sticky out bit that comes and measures depth. So those are the three measurement modes. We'll look at them all. Now, before we start anything else, the single most important thing is these angles. So this angle here has to be a true right angle because this is the axis of measurement along here. If these are set at an angle, remember that we're measuring to 0.01 millimeter. So if these are set at an angle even a little bit, then if we, for example, we put a circular thing in there to measure, then actually the angle of contact across it and the angle of measurement are not the same. So we'll actually be measuring a cosine or a sine of that length, not the actual length. Now it'll be very, very close, but it certainly will not be perfect. The same is true of these inner jaws, or step jaws if you like. Exactly the same, they have to be at right angles. Otherwise, the measurement at the tip and the measurement in the middle are going to be different. And of course they must be parallel. Both sets of jaws must be parallel, again, because otherwise the measurements at the different points along them will differ along the jaw length. Similarly with this sticky out thing, the depth gauge, the end of that depth gauge must be square. This end must be square with this. And this must exactly be planar with this surface when it's retracted. Now, how much do we need to pay attention to that? Well, it depends what we're using it for. In the electronics lab, not a lot. Because truthfully, most things that we're measuring are standard sizes anyway. So if I measure, for example, this barrel connector, it says it's 3.44 millimeters, 3.45 millimeters, something in that region. Now, it may well be that in actual fact, I think this is a 3.4 millimeter jack. So that's it. It's a 3.4 millimeter jack. So what? That's it. End of job. Because this has a tolerance of perhaps 0.1 millimeters. So I don't really need to worry too much about that. And the same if I'm measuring, let's say, the pins between something and they end up as 127.8 millimeters. Well, I know that that's probably a 1.27 millimeter pitch because that's the standard pitch in electronics. So a lot of the time, this is indicative rather than absolutely precise. So in terms of measuring whether this is square or not, obviously you could put a tri-square in there. That's a bit rough and ready, and then you'd be trying to see whether there's any light leaking through. You know, that's not really going to answer the question. The manufacturing is almost certainly better than that. In practice, the chances of this coming off the manufacturer's machine a long way off are pretty slim, and I'm not going to bother for the sake of the electronics lab. Instead, I'm going to take that as square. So let's first of all then look at our first issue. So the first issue is, for me, is repeatability. Let me just switch cameras again, I think, so we can see this easier. That's better. Here's repeatability, and what I want to see is this repeatedly going back to 0 or 0001 as I close it. Now, technique-wise, it's really important to always apply a consistent force to this when you're closing the jaws. These jaws will flex. I know it's metal, but it's still going to flex, particularly when you've got kind of like a small thing in here, and that small thing itself may flex. So you want to always apply a consistent force. Now I happen to use the wheel for that. I can get more consistent force using the wheel, and this feels quite helpful. It does actually slip, a bit like a torque control on it. It's not a torque control, it just happens to slip when it gets to a certain tightness. And I'm getting pretty repeatable zeros, so I'm happy with the repeatability at 0. Let's measure something. So this is a 50mm standard, and this is designed to set a micrometer at 50mm, and it's a magnitude better than the thing that I'm calibrating here. Now, I do need to think about this a little bit, because I'll exaggerate here, if I measure this like this, 49.9, why is that? Well, because I'm measuring diagonally end to end. I'm not measuring the actual thing at all. So I do need to get this square. Now this has got a square flat end, and I'm going to put that square and flat against that top jaw just there, and then I'm going to wind up this second jaw to meet it. And there we go. Oh, 50, in fact, 50.00. So that's really good. Let's repeat that. I'm just going to repeat it on a different point on the jaw. Yeah, make sure that it's square. Wind it up, 49.999. 49.99908. So overall, the repeatability on that is pretty good, and the consistency across the jaws feels pretty good, and overall it is pretty nice. Now, these two jaws are set at 50mm apart, and I'm also going to just kind of measure, make sure this is zeroed as well. Using the Mitutoyo, we'll see why I'm doing that in a second. Yeah, 50.000, that's fine. Okay, cool. Now I'm going to use this guy. There we go, 50.06 is the smallest I can get that to. So in other words, there is 0.06 difference between these inner jaws and the outer jaws or step jaws. So, you know, that's an important thing to know. And one of the reasons is, although it's easy to zero these inner jaws, don't do that, it can be extremely difficult. I mean, what are you going to zero those two on? So, in other words, these are not exactly correct. The other thing that I noticed with these, if I just go get a bit of paper, is that there's quite a big gap in between them. So when you're measuring small stuff, yeah, it's actually, you're not actually again measuring in that axis along there. The axis that you measure on is actually sloped in comparison, that way actually, is sloped in comparison to the measurement of axis. Now it's probably not going to make a lot of difference, but occasionally it might make 0.01 difference. So you've got a source of inaccuracy on those because they are apart. In terms of these appear to be very, very parallel indeed. We saw that it was measuring very parallel with that, and that's the ultimate test really. It should measure the same irrespective whether I'm measuring up here or down here. So I was pleased with that, and if I hold them up to the light I can't see any light between them. Now the other thing that should be correct with these, this face and this face under here should of course just touch, and they don't. We saw me passing a piece of paper between them. Similarly, these of course, as well as being parallel along that edge, should also be flat across this surface. Now, I don't know if you're going to hear this. That is the sound of my fingernail clicking on the step. I'm going to try and zoom in. I don't know if it'll work. I have to just zoom out just a little bit. So you can see this has got quite a lot of flex in there. I'm hoping this is showing up okay. It's about a ½ millimeter, maybe a little bit less of flex. Now it's not possible to remove that entirely unless you go for a lot of very, very expensive manufacturing. This is the Mitutoyo. It also has a teensy bit of flex in, but hardly any. Now the Mitutoyo is almost a knife edge along this sharp piece here. It's not quite, it's perhaps 0.2 millimeters, something like that. And it's moving perhaps not even half, a quarter of its width. This is considerably fatter along this edge. I'd say it's a good millimeter thick, maybe a millimeter and a half, and it moves quite a lot. So that's not ideal. It's probably not going to affect your measurements, but it might do. If it was worse than that, it definitely would. Okay, let's just see if it zeros. It still zeros. Nice. Let's then look at this end, which is the depth stop. And we'll have to talk a bit about measurement technique again. Okay, so I realise this is probably going to be quite tricky to see. So what I've done is I've put down a steel rule on here just to act as a flat surface. And I'm going to kind of try and balance this so that it is exactly on that surface. Now that's a bit tricky. I really do kind of need an actual sort of right angle step for this, but I'll do the best that I can. And we'll just wind this up to make sure that it's zeroed. Yep, we're zeroed. Okay, so let's put it on here. Get it nice and flat. Oh dear. So what I'm doing is just moving this backwards and forward, wiggling it backwards and forward, trying to get the smallest measurement that I can. So I'm leaning it forward and the measurement goes up. As I lean it back onto that corner, then I should achieve the smallest measurement possible. The other thing is, you can probably hear the depth stop taking it off, click it down. Okay, so I think that's the smallest I've achieved, 0.05. So I think we've got a 0.06 error on these jaws up at the top here, and we've got a 0.05 error on this bottom piece just here. What if we're measuring the depth of something like this though? I mean, this is a bad thing to measure because it will flex in its own right, but if we're measuring something like this, then yeah, I can't, what am I supposed to do? Try and zero on that edge somehow? And then what do I take my measurement off? That edge there, wiggling all over the shop. Probably the best I can do on this is to actually place that depth gauge line down the edge and measure like that, 49.02. But it's not a very easy measurement by a long shot, and this wiggles backwards and forwards quite freely. But for many purposes, it's perfectly all right. Of course, the thing to remember is I'm actually measuring the depth of this side, not the actual depth of the center at all. So to measure the depth of the center of something, we would put a big block on it, like that. Now there's two things we can potentially do here. And this is what we would have to do in this instance. So we place this on here and we run our depth stop down parallel with that. Now this depth stop, I'm obviously making sure that this doesn't swing in that direction. So it's square on the actual, this is a spirit level, but so square on the block that I'm using to measure. And that this depth gauge is in contact at both the top and the bottom. And then I can zero it. Okay. Then I can move it along. I can make my measurement and lock it. 58.47. So we can see how inaccurate that first measurement was compared to that. Now we've managed to achieve that zeroing there. We could zero there as well. There might be a difference between the two if this isn't square. So you should be using engineers blocks and engineers. There's some parallels and things like that that you can buy for engineering purposes. A 123 block, for example, 321 block. I don't remember which way round it is. They will have very good precision across their width. If you're using something a bit more difficult to do that zeroing on, something a bit thinner, then of course, so this says it's that measurement was 39.994. Now that won't actually be correct, but we go, we've got an error of 0.2 by using that mechanism, and that's because this isn't an inherently accurate thing that I'm using to measure off, but I think we get the general idea. We need, if we're going to measure something deep like this, we need a square block on the front so that this can be squared in all directions. So I guess that's it. Some thoughts on the key points. The fact that this face here should be flush with the depth gauge. These should be parallel. These should be parallel. Obviously, these should be square with the axis of measurement. These should be square with the axis of measurement. This should be square with the axis of measurement. Everything should be square. And this doesn't hold up too badly, to be honest. In terms of squareness, I think they're probably fine. I haven't measured the squareness, but I've got no reason to doubt it. The accuracy is fine. It measures my 50mm standard as 50mm, which is pretty good. 50.01 for 4999 would have been equally acceptable. The repeatability appears to be spot on. I don't have any problems with the repeatability. It seems to just keep measuring the same time and time again, which is important. Probably more important than the inherent accuracy, because it's ultra accurate, but you can't get the same measurement twice. Yeah, what's that about then? That's no use. So yeah. The roller is not bad. It feels pretty smooth, certainly better than sort of a cheap one from a supermarket or something like that. Compared to this, I mean, this is silky smooth. It's just beautiful to use. This is okay. One of the things you can do on the Mitutoyo is you can use this as a tension screw. This on this one tends to be either lock or not lock. It sort of works as a tension screw, but yeah, you don't need to worry about this scuffing the top, because there is a bit of spring metal in here to act as sort of like a brake. So you're not kind of screwing that into the actual stainless steel bar. So my conclusions. For the electronics lab, I'm completely happy. Don't really have any problems. It's not perfect, certainly, but visually it's quite nice. It's a shame it's not a little bit more matte. I'm going to have to be careful with reflections when I'm doing videos, but generally speaking, the big display is helpful. It feels nice. It's a bit, to be honest, it's a bit heavy at the front, but yeah. But other than that, I mean, you've got to get that glass in there. You've got to get the display in there. There's not a lot of choice. It's going to be fairly heavy at the front end. So yeah, nice. Accuracy wise, happy. Build quality, pretty happy. So accuracy, I'd give it a 5 out of 5. Build quality, I'd probably give it a 3 out of 5. There shouldn't be quite as much. There's a lot of slop in that. There shouldn't be that much. It should have been machined a bit better. I can't really see the machining very easily. If I kind of look from this end, I can kind of see it. The top one looks clean. The bottom one, its friction section is ground onto the solid metal, which I suppose you'd expect, sort of. But the gap though is a bit wide. Yeah. Anyway, not too bad. So yeah, build quality probably a 3.5 to a 4. Accuracy and repeatability, I think they're both 5s. They're fine. In terms of the main jaws, that is. In terms of these jaws, I'd only give those a 2. They shouldn't have that big gap between them, and they should have been machined to be zeroed at the same time that these are zeroed. The only place you can really do that is in the factory. That's not acceptable. And the same with this end, really. That should have been zeroed. So still, overall, I'd give this sort of a 4 out of 5. In terms of electronics lab usage, perfectly acceptable. In terms of using it for metalwork and things like that, it's okay. I wouldn't use this for anything where I'm going to be using these or the depth stop particularly. And the depth stop we do actually use quite a lot in metalwork, because often, as I described, we work off a plate to do measurements. So the depth stop is quite important. But in fairness, I would probably use an actual depth gauge for that purpose. So it's okay, perfectly usable. perfectly adequate for most general use. £29.99 I think these were, so they're not breaking the bank, but they're also not the cheapest on the market. For that price, yes, you know, I'll give them a 4 out of 5. I would have given them a 5 out of 5 if they'd just paid that little bit more attention to the build quality and the comparative accuracy between the different points. Hopefully that gave you a bit of a feel for what these calipers are like, and also a feel for some of the things to think about in terms of buying cheap calipers in particular. You would expect in an expensive pair, £100 set of calipers, you would expect all these things to just be right. But even then, you should go ahead and measure them. And the amount of effort you put into measuring these various things would probably depend upon the price you paid for them and your end usage. Anyway, there we go. Hope you enjoyed it. If you did, please give it a thumbs up, subscribe, and I'll see you next time.